Morning, everybody. We're about 20 seconds away from kickoff. We'll just let everybody grab their seats, teas and coffees and whatever it is you're doing. All right, let's begin. Kia ora tēnā koutou whānau. Welcome to our number 8 webinar in the Nuralite Education series. For those of you who haven't seen them before, we actually record these all, and they're all available on our education webpage. Nice, short, sharp 30-minute session. We appreciate your time is very precious to you. One of the things we do with our webinars is typically when we go and see a group of architects, we'll take a plate of sausage rolls, and of course with COVID-19 lockdown, we can't do that. So what we're going to do in this situation is we're going to donate $10 to every attendee to Starship Children's Hospital this time. We've done that regularly through all our webinars. It seems to be received quite well by the groups. Today we're going to talk to you about roofing penetrations. Now, one of the benefits of a membrane roof is that you can actually successfully penetrate the roof to create things like soil stacks, solar panels, fixing plates, rain screens, HVAC equipment, all those types of things that are usually a good place to be put on a roof. So just before we start, I'm going to kick off with a poll. This gets your fingers nice and ready and allows you to participate in this. These things are a bit awkward. They're sort of talking into a black hole. So the more that you guys contribute back, the better. Feel free to chuck your questions in the chat or the Q&A section as we go. Just want to kick off with the first poll is, from your perspective, have you ever had an issue detailing a penetration or a fixing on a membrane roof? Quite keen to get this sort of feedback, and we'll actually share this with you. On the panel with me today, I have the wonderful Rod Southwood, our National Client Manager from Nuralite. Although he only looks 21, he has many years experience in the waterproofing industry and has probably seen the good, the bad and the ugly, and he's going to talk to us about his experiences. Also very grateful to have Shay Braizer here from Revolve Energy. Shay's got a extensive background in solar panel design and consultation. He's a little to do with windmills and all sorts of weird and wonderful things too. He's a bit of a clever man, so we're really pleased to have him here, and he's going to give us a bit of a run over of one of our case studies that we've recently completed. Did we share those poll results? Did we guys see those come up, guys? We can share them with you anyway. So what we do with these webinars is we record them. Any of the questions that we can't answer within the 30 minutes, we actually take note of them and then answer them in writing, and you'll get the full copy of those. All right, I'm going to throw you over to Rod Southwood, who's going to be talking to us about how we should be detailing our penetrations. He's going to give us some successes and failures of roof penetrations and the types of things that we can put on our roof. Over to you, Rod.
Yeah, thank you, Shane, and welcome everybody. Yes, so penetrations. Obviously, yes, in my time, I've seen lots of penetrations. To be fair, a lot of them are ugly. A lot of them require a lot of detailing and difficult detailing. So at Nuralite, we're always looking for the best product to join our range of materials, to minimize detailing and give you the best outcome possible. So this slide here is showing you the Nuralite Fixing Plate. This particular version is Nuraply TPO. This fixing plate is fast to install. In fact, one of our contractors recently installed 60 in one day on a house out in Piha for solar panels. And that was fitted and waterproofed in that time. So what this fixing plate is doing is taking away a lot of onus on detailing and giving you a quality structure for adhering and bolting other items too, which we'll touch on shortly. So yes, here's a couple of cases of penetrations. Sometimes they can start out ugly and they just get uglier and uglier as time goes by. As you can see on the left there, we start out with a penetration with torch-on membrane, and then we move into some sealants as problems arise, and then we move into some liquids or some paints to try and help that along. Obviously not ideal. And the one on the right's a torch-on one, which obviously keeps changing and keeps getting repaired. Obviously here we've got numerous patches, which is not ideal. We're also now installing metal cowlings and silicon sealants. So we're trying to take a bad detail and try and keep it watertight with the addition of all these other items, which in the scope of things is not a great thing to do. So I see hundreds of penetrations through my time and site visits that are similar to this and sometimes worse. So at Nuralite, we're just striving to give you the best quality scenario when penetrations are involved. And as I said before, that's a quality component with ease of detailing, and that's what we're looking for. Okay, so here's another couple examples of the fixing plate. As you can see on the left, this is supporting a timber member, which is supporting a timber range screen. And on the right, we have solar panels. As you'll see, the fixing plate itself has a stainless steel lug, which is on top of that, which these units are bolted to. So in saying that, these units are factory assembled. So the lug on top, the stainless steel lug, which has two female M10 threads within that, factory assembled in Europe for us. And the waterproofing between that stainless steel lug and the membrane is warranted by the factory. They are like a Loctite scenario, so they do not get loosened or moved from that plate. Basically, the units are screwed down to a substrate with our own Eurofast screws, which we also import from our own supplier in Europe, and these are coated screws. These screws are suitable for timber, they're suitable for metal tray, and they're suitable for concrete. When it comes to a warm roof scenario, we obviously have thermal break flanges, which I'll touch on shortly. The interesting thing with these is the downward load is around 250 kgs per unit, and the wind uplift with the 8 fixings is 5 kN. So 5 kilonewtons of wind uplift. These units are ideal for planters, solar panels, air conditioning units, and bear in mind that the weight of an air conditioning unit, if you think about it and place them right, you can actually have some aluminium or some metal rails that you can place between these units, and those rails will then take the air conditioning units that you want to the desired weight and wind uplift. So there's a lot of variety around the way you can structure this. They're also good for walkways, pipe and wire conduits across the roof. Obviously weather screens, as we're seeing on the left. So these products have a lot of advantages. They are warranted with the Nuralite warranty. So the 20-year Nuralite warranty, these are all part of that full warranty, so peace of mind. The units themselves, they weigh around 3.5 kilos. That's with the membrane. And these units we have with both our TPO and our Nuralite 3PM membranes factory fitted, ready for installation. At Nuralite, as you may have seen before in some pics, we like to hold a good amount of stock. We generally try and hold around 70 or 80 of these in stock. However, it's also advantageous to let us know, as we may need to get more in depending on the size of job. I touched on the TPO and 3PM, which is great. These components are also available to view on our website at Nuralite. And if you simply go to products and components, you'll be able to find all of the data. So the data sheet that we have, like I said, will tell you the fixings and the KN, how many you need for the uplift that you want. Yeah.
Excellent. So, I mean, you've seen the good, the bad, and the ugly, Rod, in your experience, but what you're saying is that membrane penetrations can be done successfully?
That's correct, Shane. Unlike plinths and other means of achieving this, some old universal bracket type details, which are time consuming, very complex, these are definitely a way to do a penetration with confidence. And as I've said before, we always look for the best material and also reducing the effort involved in detailing them. So having the membrane on these units with a 150 overlap over the actual size of the plate being a 300 diameter coated metal plate with the holes already preset in that plate. These holes are set for both Eurofast screw fixings, as I said before, which can go directly into timber or concrete. And we also use, the holes also have a larger size scattered through this plate for the thermal break flange that Nuralite provide for our warm roof systems. So you don't end up with a thermal break in your system.
Nice one. Nice one. Cheers for that, Rod. We'll come back to you later on and you can show us through the detail of the fixing plate and how we assemble it and things like that. Next up, I'm going to introduce you to Shay. Recently worked with him on a very interesting case study. Shay's going to tell you a bit more about himself. I think his background's quite interesting, what he's been up to. And yeah, give us a bit of a rundown of some of the challenges he faced with the latest case study. Over to you, Shay.
Great, thanks, Shane. Yeah, my name's Shay Braizer from Revolve Energy. We're consultants working in photovoltaics, but also behind the meter energy control solutions, including batteries and electric vehicle charging, and control things like heating and lighting. So we came to meet Shane on the Emirates Team New Zealand project, which I'm going to talk about. The Emirates have Genesis Energy as one of their major sponsors. So Genesis supplies electricity to the building, and as part of the agreement, they agreed to install photovoltaics on top of what was previously known as the Viaduct Events Centre. And as you'll notice from the roof, it's quite a special roof. And when we first met with Gordon Moller, there was obviously quite a lot of concern about how we might actually mount the solar on there and do that effectively. So the initial concern was around twofold. One was architecturally, how are we going to maintain the form of the building? And secondly, how are we going to ensure that we maintain the water integrity of the roof, which I think had a lot of detailing done to make sure that it could last the test of time. So what you can see there is a curved, more flexible solar module, which is fitted on top of the roof. Typically, solar is a square glass fronted module, 2 by 1 meters, and that's attached to a mounting rail, which is then fixed to the roof. In this situation, it was felt that wasn't appropriate because we'd need a lot of fixing points right across the roof, and architecturally it would significantly alter the look of the building. So we opted for a curved photovoltaic module, or flexible photovoltaic module that could be bonded down onto the roof. Would you like to just flick to the next slide, Jay? So this is a shot looking down between two of the vaults. So you can see, if you can see my mouse, you can see this area here. These are the photovoltaic modules. So they're about 3 meters long and about 1 meter wide, and they are physically bonded down onto the roof. So there's an adhesive applied, usually in the factory, to the back of the module, and then that's adhered to the roof. And then you can see here the fixing points that were, these here are the Nuralite fixing points that Rod was just talking about. So we use those for the cable containment. So we use those because there was a lot of concern about maintaining the warranty of the roof from Facilities Auckland. So these follow the route of the cable containment, and the cable ducting just bolts direct down onto those, so we can run the cables over top of the vault, along and down the roof. So it was quite an interesting project for many reasons, but mostly because it was just such a challenging roof, and I think the outcome has been great. Yeah. So if there's any, I think you had if there's any quick questions, I think we're going to answer them at the end.
Yeah, I've just got one that's just popped in now. So, these PV panels, they're thin and flexible and curved. They're a little bit different to the solar panel I had in my 82 FX calculator in fifth form. can you just tell us a little bit about the evolution of the solar panel? I mean, these look relatively new.
Yeah, so when I first started working in solar in 2006 in London, it was very early days. And probably the predominant technology that's still used is this crystalline silicon, so the square cells on a glass sheet. But over the years, there's been a number of thin film technologies which have been introduced, which allow the module to flex. So they're put between plastic substrates. So this is this one is SIGS, cadmium, indium, gallium selenide, I believe,
Wow.
which is basically, in effect, it's a vapor deposition. So it has a very thin layer of it applied on top of a substrate. Probably the biggest change in technology over the years has been to do with the cost, just how much cheaper they are to produce now. And every year they've got a little bit more efficient, which also helps because you need less framing, less modules, less installation work to put up the same amount of solar. So we've gone to the point where in 2006, it might have been $15, $10–15 a watt to install them, to now where it might be $2 a watt or less for bigger systems, which means you can generate electricity for the price at times of the wholesale electricity market now. So in New Zealand this year, we've seen significant interest, because I think there's a realization that solar's got to the point now where it can really compete and make a difference on buildings. So the image you saw on the introductory slide for myself was from the Foodstuffs PV project, where we're currently installing about 3,000 modules on a 6-hectare building.
Wow.
So that'll generate the equivalent of all the energy of the office building next door. So it's, if you consider the scale of Foodstuffs and the price they pay for power, I think it's a real indicator of what we're going to see in the future.
Oh, that's excellent. No, thanks for that overview. It's interesting to see how far those panels have come. We're just going to flick back to Rod now. He's going to give us a bit of a rundown on two of the penetration options that Nuralite has. One is the fixing plate, and the other one is the lock-in pocket. Do you want to kick off with the fixing plate, Rod?
Yeah, sure thing. So while I talk about that, or just slightly before, I've got a goodie here in front of me, and I'm not sure if you can all see this. Hopefully you can, but this is our fixing plate. This is the underside. Can we see that? Okay. Okay, so this plate is coated. It already has the holes pre-drilled, as I said before. Eurofast screws to concrete deck or timber, the smaller holes. The larger holes, which there's 8 of, for our thermal brake flange to come through. And also on the other side, this one is a 3PM membrane. And as you can see, hopefully there, the stainless steel lug on top with the 2 M10 female threads. This is a 75 diameter by 25 high stainless steel lug. As I said before, factory fitted and warranted, minimizing detailing, and also obviously advantageous for waterproofing integrity. So this detail here, obviously, yes, is showing the Nuralite fixing plate on a 3PM warm roof. We have a metal tray as the substrate in this example, with a vapor blocker that we place on top of the metal tray. That's an aluminium foil true vapor blocker. We then fit the PIR board to the design thickness for R values that you've chosen. We then install the 2-layer 3PM membrane system, the vented self-adhesive base sheet onto the aluminium foil, minimizing flame to the board and to the area, and a 3PM mineral cap sheet on top. As I said before, these plates we import with our 3PM mineral membrane already on them. So that plate is simply screwed into place with the desired fixings based on your KN, your wind uplift requirement. And then the membrane is welded around that to the existing membrane. So in these scenarios, the 2 layers of membrane in this case, or if it's TPO, the single layer of TPO is applied to the warm roof. Then the plate is installed with the fixings that are appropriate, and then the membrane is welded. There's a 150 skirt. So as I said before, the plate's 300 diameter. The membrane we put on the plate is 600 mils diameter. So we have a 150 mil bite right around that unit. And obviously, as I said before, the lug has 2 N10 female threads, and it is stainless steel. So being in a wet dry cycle like it will be, it's not trapped within the roof plane, it is outside. Just ensure that your metal components that you put on top of that are compatible. So check that with your Google or your brand's compatible metals chart. So obviously you're in keeping. If anything fancy comes along, just ensure that that's done. But the Nuralite fixing plate we've brought in for obvious reasons, for that strength, for the weight of download, for the wind uplift, and the ease of detailing. So you're taking away complicated detailing like you might have in a plinth or an old universal bracket. So it's simplifying it for the installer. The simpler we can make things and the better we can make things, the better the end result. And here we have a typical CAD detail, 2D CAD detail of that exact same scenario. So that is showing you the fixings, the thermal brake flanges, the Eurofast screws going into the plywood below. And as I said before, that could be any substrate, that could be concrete, any type of timber or metal tray. And the membrane is welded to the circumference. So like I said, we're trying to simplify the detailing and give you quality. This one here is a lock-in pocket. So this is a fantastic way of dealing with difficult penetrations. Now penetrations, and maybe you have a situation where the penetration, it might not be difficult, but the penetration is close to an adjoining wall. So for example, on the odd site that we get to, the designer has no option but maybe to put a downpipe in a situation where it's difficult to detail behind that downpipe. So the lock-in pocket is advantageous in that scenario, as well as difficult penetrations. So as you can see here in this detail, we have a surround, which is a polyethylene surround. Sorry, it's not. It's a two-component polyurethane rubber surround that's set onto the finished membrane, and which we're pointing to, which is set in an LPS Millennium sealant. And then inside that, we pour in through a dual cartridge battery gun operation, a liquid 2-pack polyurethane semi-flexible material. Being a 2-part cure, it is an even throughout cure. So it gives you about 15 minutes rain resistancy, and in about 30 minutes it's cured. And yes, it is semi-flexible. So if there's any vibration, any movement, then this product is not rigid. It's not going to crack. Its adhesion is fantastic to a large variety of substrates for penetrations, varying types of metals, PVCs, etc. There's a degree of prep required for those, but they're taken on a case by case as to what they are. Here we have a classic case where the lock-in pocket's been utilised on some large metal H beams that are in a very prestigious West Auckland large building. The issue here was not only was it an H pile, which makes torch membranes a little time consuming to detail, but this one also had an anti-ponding plate welded to it, which was about 1 inch thick, 25 mil thick, as you can see just above the lock-in pocket. So the lock-in pocket in this instance was a fantastic way of waterproofing our 3PTM tanking membrane, which is lying there on the compacted hardfill, and waterproofing that H pile. And there were hundreds of these in this project, and this was a real saviour to the project for that difficult detailing. Here we're going to show you a wee video, I think that was yours truly, showing you how the lock-in pocket is installed on a difficult penetration. That penetration was solvent wiped and prepared prior to this. What we're doing here is we're ensuring we have 50 millimeters minimum of liquid in all directions around the penetration. I'm now marking with a blunt tool, as you'll see, the outer line of the pocket. This is the Millennium LPS sealant that we then place around the penetration to the 3PM membrane. What we want to do here is ensure that none of the liquid escapes. We're also going to place that sealant in the center approximately of the formed unit that's going to hold the liquid. So this sealant is going on roughly in that centered location, as you'll see. Also, this is actually a pre-made unit. We have a variety of sizes to simplify it. That sealant is placed in that dovetail join there, and the lock-in pocket is pressed into place. Once that's pressed into place, you can, we'll seal up the exterior, which will obviously hide that mark that I've made. Bearing in mind, you could make that mark on the inside if you so wish.
It's a very, very tidy sealant bead there, mate.
Oh, thanks, mate. I've done a few meters of that in my time. So obviously what we want is we also want it to look aesthetically pleasing as best as we can, given what we're doing. And now we're filling it up with a 2-component hurricane liquid. As I said before, that's a 2-component polyurethane, fast-setting, semi-flexible liquid. And that goes in relatively quickly with the battery-powered gun that we bring in with this material. And the air bubbles in the top there do disperse as that starts to cure up. And voila, you have a nice sealed penetration. Now, just to top that off, when the bubbles escape, that's actually not a bad finish. If you do want to make that more decorative, you can put on some 3PM membrane over the top of that with a small torch. That can be dressed up to look like the roof surrounding it, or it could be brushed on with a liquid we have called MS Detail, which is from our ICO supplier as well, and we supply chip that matches the membrane you're doing, so that could be sprinkled out with chip. So we can really disguise that lock-in pocket and blend it in with the surrounding membrane that you've chosen.
Excellent. It looks like a magic little tool to have in the kit to do those tricky penetrations.
Absolutely fantastic addition to our accessories range. And as I said before, Shane, we're forever striving to find the best way of dealing with a penetration with ease of detailing and take a lot of that aspect away from the job. As you'll see here, these are the fixing plates yet again on a 3PM roof, ready for some solar panels. They are under the same Nuralite warranty as the full system. Yeah, which is fantastic. Excellent. And they are also, I should point out, within our code mark. So they are a code mark item, a code mark accessory within our code mark criteria for 3PM. So it's belts and braces and comfort.
Excellent. Oh, thanks for that little rundown. We've got about 5 minutes left for a bit of a Q&A session. We've had a few coming from the field, which is great. Shay, we're going to pick on you first. I'm not sure, there's a question here around payback period. Do we still measure solar panels and things by that now? Is there a payback period versus the cost of the initial install? And would that be different for a sort of residential versus commercial type project, sorry?
Yep, yes, typically we're seeing, simple payback is the sort of simple metric that's used. It's not always appropriate, depending on how it's funded and what your return on investment is going to be, but often we're seeing paybacks now of 10 or less years for solar installations.
That's obviously changed. It's a lot sooner than it has been previously.
Yeah, it's come down a long way over the years. I mean, some of the metrics around what you get paid for the energy when it's exported have changed as well, which has made it harder to get that return, but PV prices have just fallen so quickly that it's kept up.
Yeah, right. And what about the life cycle longevity of PV panels now? How long are they lasting?
Yeah, most PV modules will have a 25 or 30-year power output warranty and have a 10-year manufacturer's warranty. So we're expecting them to last 25 to 30 years, typically. And I think the question there related to, if I understood it correctly, if you're putting them on a membrane roof and you're sticking it down into the roof, how does that work in with the life of the roof? I think that's a very important point because they're not easy to take off without damaging the roof. And when we looked at it with the Emirates Team New Zealand building, we were looking at how does that align with the next major service of the roof? And in this case, it aligned very well. So there wasn't a concern about that with this project.
Excellent. I've got one here for you, Rod. How do we deal with the lock-in pocket on a slightly pitched roof, and can we do it directly to the substrate if it's not a warm roof?
Yes, well, obviously the roofs are on a very slight slope. Basically, when you get to a 2-degree scenario, the liquid may be around 5 mils shy of the inner side of the higher end of the pocket. That's not detrimental. The upper part of that pocket, given how the aesthetic nature of where it might be, that can be trimmed off with a sharp big knife. It is a rubberized component that surrounds, so it is easily trimmed down. So we just certainly trim that down to give it an aesthetic appearance at that point.
Excellent. I've got a question here. I think I could answer this one. They've asked, what does the introduction of solar panels over the top of a membrane roof do to the warranty? Now, we do know that unlike metal roofs, the membrane roofs don't need continual rain wash, etc., to maintain the warranty of the coating. For example, the 3PM membrane we're using on the roof is very, very similar to our tanky membrane. It actually gets buried below ground for 50 years. So we're quite comfortable from a solar panel point of view, having solar panels sitting over the top of the membrane. The key is actually detailing these penetration points is probably the key to it. And if we stay in keeping with these things we've talked about today, we're within the scope and limitations of the code mark, and we're also going to be able to obviously honour the product warranty. Is that an issue that you see with metal roofs, Shay? Does that come up often?
Oh, it's a really big topic, particularly on the larger commercial roofs. We're very, very aware of that issue, and we're designing the frames to make sure that we can wash them. And often we're asking for method statements for how that washing is going to be undertaken over the life of the roof. So it's it's a real factor.
Everyone should just do membrane roofs, will be sorted. Right, let's have a look here. I do have a couple more questions that have just come through. I'll just flip through them, sorry. How much power does the Team New Zealand installation generate?
I haven't got the exact figure in front of me, but I think it'll be about 80,000 kilowatt hours per year.
What does that mean?
A typical house might use about 10,000 kilowatt hours per year, so about 8 times the typical New Zealand house.
All right, okay. Excellent. See if I've got any more here. Sorry, guys. Someone's asked about the battery life for a PV. Is there a battery associated with a PV panel? Is there? Or?
Yeah. So historically, PV was always installed as part of an off-grid system where there would be a battery. But most of the installations we're doing now, the PV is connected via inverter directly to the building's AC supply. So
right.
There's no battery involved at all in most cases. So any energy is generated and used directly in the building or sold to the grid. If there is a battery, then the life of the battery depends a lot on its use and its technology, but it might be 5 to 10 years, hopefully 10 in most cases.
Okay. I've got time for one more here. Are the solar panels far enough away from the roof to prevent heat buildup underneath? I'm not sure if they're referring to the Team New Zealand installation, because they're directly on the membrane, aren't they?
Yeah. I mean, perhaps the PV panels do degrade. Their output is reduced as they get hotter. So certainly the ones on the Emirates Team New Zealand roof will get hotter than modules that are installed above the roof where there's an air gap.
Yeah, right. I do remember that's something we did look at, and the melting point of the Tactic polypropylene modified membrane is around about 160 degrees, and the surface temperature of the panels wasn't going to get anywhere near that. So I knew we were pretty safe from that regard. So.
Yeah, it's definitely one of the downsides of sticking them straight to the roof, though.
Yeah, right. There's some good questions here. We're 1 minute over, but what are the costs of the flexible PV panels in relation to normal standard ones?
Yeah, that's a great question. I thought someone might ask that one. Because they are produced in small volumes, they're definitely more expensive. I haven't got the figures in front of me, but yeah.
Okay.
Definitely more expensive for the module portion.
Excellent. All right. Thank you very much, panelists. We'll wrap it up now. There are a couple of questions that are sitting there unanswered. They will come out in the final document. We'll wrap it up in full. Just a quick recap. One of the benefits of supplying a sheet membrane is that the sheet membrane is actually made in the factory and arrives to site. Waterproof. We're actually relying on human beings to install it. Traditionally, penetrations, those horror shots that Rod showed earlier, were man-made or field dressed, if you like. we now sort of have that ability to move away and have sort of semi-pre-made penetrations, if you like, to sort of guarantee the waterproofness and take that the human factor and minimize it. So we are, able to successfully penetrate these membrane roofs. Thank you, Shay, for your input there. Very interesting case study there. I quite enjoyed working on that one there. Now I'm just going to finish up with a poll here. I've got a poll on basically rating our presentation. We'll flick that up there, and keen to get any feedback to make sure that you're getting the most out of this. Yeah, give us your feedback. Let us know if we should just stick to our day job or carry on with these. And then we'll also give you the opportunity in the next poll to let us know if you'd like a follow-up, if you're working on anything at the moment you need some assistance with. We're all here to happy to help. So that was the Nuralite penetrations webinar. The next webinar we will have is in a week's time, I believe, and that is on the Architects Declare clause. We'll be lucky enough to have a panelist with us on that one, Duncan Sinclair, who'll be talking about the Architects Declare movement. So this webinar, all the previous webinars, and obviously all the prior webinars will be advertised on our website. You can go through and click on those and access them. And if there's any topics that you'd like us to talk about, there's actually an opportunity there for you to provide your feedback there. Actually, this is where some of these topics have come from. They've come back from the design fraternity asking us to talk about particular topics. So we really look forward to presenting those to you. Now, we did go 2 minutes over time. Apologies for that. Thank you very much to the panelists. Thanks very much for tuning in, and thanks to everyone in the Nuralite team in the background pushing all the buttons. Thanks very much.